Today's video is an introduction to half reactions. In many redox reactions, metallic atoms become ions or metallic ions become metallic atoms. We can use half reactions to show the loss or gain of electrons that occur in this process. In the case of zinc atoms, they must lose 2 electrons to form zinc ions. Copper ions must gain 2 electrons to become copper atoms. If you are given a reaction that shows the transfer of electrons between zinc and copper, you should be able to figure out the 2 half reactions that are involved in the process. You can start by separating the 2 metals into different reactions. The first reaction would be the change of solid zinc to a zinc ion. Notice how the atoms are balanced here, but the charges are not. To balance out the charges, we need to add in electrons. Assume that each electron has a charge of -1, so 2 electrons are required to balance out the +2 charge of the zinc ion. The other half reaction is the copper ion to copper solid. Once again, we need to add in 2 electrons to balance the charge. If you were to combine the 2 half reactions, you should end up with the reaction that you started with. Here is a more typical example that you might encounter. Single replacement reactions are very common in redox chemistry. This reaction involves solid lead and silver nitrate. The non-ionic reaction shown is a balanced chemical reaction. The total ionic equation is what we get when we divide the ionic compounds into their ions. This process is done to work towards the net ionic equation. Here we have the net ionic equation. This is helpful to us because it will allow us to eliminate the ions that are not directly involved in the reaction. Here we can see that lead and silver are involved in the redox reaction. Solid lead becomes a lead ion by losing 2 electrons, and the silver ion becomes solid silver by gaining an electron. When we divide the net ionic equations into its parts, these are our half reactions. In the example with lead and silver nitrate, we should be able to identify the oxidizing agent, which is silver, and the reducing agent, which is lead. Please complete the October 5th quiz.